Hello and welcome to the Introduction to Geometry. In this section we're going to just kind of look at a few definitions and kind of take note of how things are going to be noted, and also look at kind of how we're going to start measuring things like angles and stuff like that. So to begin with, we're going to first start out by looking at some definitions. Okay, so one definition that we have to know is a point. Now keep in mind, a point is a location in space. It does not have a size, a height, or any type of a depth. Okay, and your point is going to look something like this, and typically we're going to label it with like a letter. Here we would say that this here is point A. Okay, we are also going to encounter lines. Now a line is defined as a straight, unbroken set of points that goes on forever, and it has an infinite length, but it has no thickness. Okay, so we look at a line, or this is how we're going to show it here in geometry. Okay, notice that this has 2 points on that line, so we can call this line AB, or so AB would be this way, line BA would be this way, and notice we indicate that we have a line that goes on in infinite directions, and we label that with this double arrow above the 2 letters. So this tells us that we have a line AB or BA. Then we're going to identify a plane, and a plane is just a flat surface that has a length and a width but no thickness. So kind of like if you want to think about maybe looking at like a piece of paper from the top, okay, where you can see it has a length and a width, but you can't see the thickness of that piece of paper. We also have what we call line segments, and the difference between a line and a line segment is that a line segment has an end. Notice I do not go through the points like I did with the line. We have a definite beginning and a definite end. So we denote a line segment with just a solid line above the 2 letters, to where before we had the arrows on each end to show that it went on in infinite directions. Okay, and again we can call it line segment AB or BA. And the last thing that we have is what we call a ray. A ray is a line that has one endpoint, and it's going to continue on in the infinite direction and the arrow is going to tell you which direction that is. Okay, so when we are naming a line or a ray, we have to name the endpoint first. So notice in this case here, I can name this ray in 2 different ways. I can either say that it's ray AB, which would be this ray here, or I can say that it's AY. But either way, I have to start out with the letter A because that is the endpoint of that ray. And then if I look at this example down here where I have the line segment FZP, okay, I could name the line segment FZ. I could say ZP. I could say FP. Okay, these are all different segments that I could call out from the line that's given right here. So for example 1, it says name all of the points. So if you notice, I have a point right here, so I can say that's point W. I have a point at H. I have one at K, so I could say W, H, K. And although 1 is not necessarily given there, we can see that we have this point of intersection, so I could actually list T as well. For the next part, it says name 4 different segments. There's many different segments that you could name. Okay, I could name this segment right here that goes from W to T. So if I have WT, I just have to remember to write the segment above it. I could do T to H. I could go T to K. Again, I'm putting the segment above it. Or if I wanted to, I could actually do the big segment here, W to K. For the next part, it says write 5 other names for line N. So with this one, we could start out by doing WK. That one would be an easy one. And that's going to go through the points W and K. So WK. Now because I want to show that this goes on in infinite directions, I do have to have the double arrows. I could say TK, which would be this region in between here. So TK. I could also say the reverse of that, which would be KT. I could use, I could go backwards. I have WK listed first, but I could also do that in reverse too. So I could say KW and put the line in sigma at the top. And then I also have, I use TK. I can also go TW if I wanted to. And that would give me 5 there. So finally, I have 5 different rays. So if I look at a ray, I could go from T through K and make my ray start at T. Because remember, you start out with the endpoint, and I do have to show the ray at the top. I could do TH, which would be this ray. I could go TW going in this direction. I could do WK if I wanted to do this whole thing. So I could say WK. I could also go the opposite of that and say KW. Okay. I could go HT. Actually, no, I could not do HT because I need to start at my endpoint, and my endpoint is T. So that right there would be 5 different rays that you could use in this example. The next thing we're going to do is we're going to look at some angle basics. Okay, when we look at an angle is something that has 2 rays and they connect at what we call the vertex here. So in this case, when I look at this picture, the vertex is at F, and the vertex is defined as the common endpoint of 2 rays of an angle. So some different ways that we could name this angle is typically if you're going to use all 3 letters, you're going to have to put the vertex in the middle. So I could say that this is angle EFD, which is what we have right here. I could go in the opposite direction and start here and say that I have DFE right here. We could go ahead and we could name our angle by just the angle or the vertex itself. And notice I do have the symbol that we use to represent angle is kind of like a less than inequality symbol almost. So I could say just angle F. And because I do have this number right here in the inside of that angle, I could also name that as angle 1 as well. So when dealing with angles, I also need to know a few things about them. And one of those things would be I need to know what an adjacent angle is. So an adjacent, something that's adjacent means that it's next to. So when we're talking about adjacent angles, we are talking about sharing a vertex and a side, but no other points on the inside. So here, notice that I have angle CFE. So that angle is adjacent to, and we'll change our color here, EFD. Okay, so these two share my vertex, which is right here, and they share this side right here in the middle, and that would be it. What's not going to happen, okay, is I would say CFD and EFD are not adjacent because EFD is inside of CFD. So adjacent means they have to be next to. So that would be like this angle and this angle. We also sometimes run into things called vertical angles. And vertical angles are formed by 2 intersecting lines, and they are opposite of each other. Now the nice thing about vertical angles that you're going to see is they have the same angle measures. So when we look at this diagram over here on the left, we can see that angle 1 and angle 3 are what we call vertical angles. So if I was told that angle 1 is 100 degrees, I would automatically know that angle 3 is 100 degrees because that's one of the nice properties of a vertical angle. Likewise, I know that angles 4 and angle 2 are also vertical angles, and these will have the same measure. We have something called congruent angles, and congruent angles just means that we have angles that have the same measures. So angles 1 and 3, because they're vertical angles, are congruent, just like angles 2 and 4. And the symbol for congruency, as you can see, is kind of like an equal sign with a little squiggly on top. That means congruent. When looking at angles, we often need to classify angles, okay? And we have a couple key terms here that we're going to use. 90 degrees is kind of, this one right here is our 90-degree angle, which is our right angle. This is what forms kind of like that perfect L, okay? Usually a 90-degree angle is indicated with the little square in the corner to show us that we have a 90-degree angle. If I have an angle that is less than 90, then we call this an acute angle. So think about it. Usually like tiny things are really cute. So you have an acute angle, which would be less than or smaller than 90 degrees. If I have something that's greater than 90, I have what we call an obtuse angle. Now, it's greater than 90, but it does have to be less than 180. In a straight angle, or like essentially a straight line, this is going to produce something that is 180 degrees. So an obtuse angle has to be in between, it has to be greater than 90, but less than 180 degrees. When we measure angles, we use a tool called a protractor. This right here is what we call a protractor, or what a protractor looks like. If you have not used one, we are definitely going to be using them in class. And what you're going to do to use a protractor is you are going to take your angle and you are going to put the vertex of that angle right on the center of your protractor here. Sometimes there's a hole right there. Sometimes you just have to look kind of like where the horizontal and the 90-degree vertical line intersect, but you're going to put the vertex of your angle there. You always want one side of your angle to be on the horizontal, and then you can see right here, I'll do this in blue, this angle here is actually coming up through here. And if you notice, this angle right here is less than 90 degrees. So on my protractor, I'm looking in the inside numbers right here. So I can see like this right here is 80 degrees. And if I look on my protractor, it looks like this angle here is about 85 degrees. That would make sense because 85 is less than 90, and I know that this is an acute angle, or an angle that is less than 90. Now, I do apologize. We'll go over how to do some more of these in class because it looks like my angles and my protractors did not line up when I brought them in from PowerPoint and put them into this program here. So again, just to refresh, we're going to want to take this vertex and put it right there. We're also going to want to turn our protractor so that this horizontal line actually falls on one edge of my angle, and I would just turn it so it falls right here. But again, we'll talk about this in class. And the same thing goes for this example because this one also did not come through correctly. Now for our last example, we're going to draw a 120-degree angle. So in order to do this, what we're going to do is we are first going to draw a ray. Remember, a ray has a starting point, and we're going to put another point, but the line is going to go through the point, and it's going to have an arrow point in one direction. So in this case, I've got ray YZ. Next, we're going to place our protractor over top of that ray, and again, we want to line up the center of our protractor, and we want to put the ray on the horizontal axis of that protractor, and we want to make sure that our YZ passes through 0, okay, which is what's going to happen over here if you look at the scale. Next, we're going to want to place a little tick mark up at the 120-degree mark. And now keep in mind, 120 degrees is going to be greater than 90, so I am going to have an obtuse angle. And then my final step would be to remove my protractor and connect that tick mark that I made Okay, and if you wanted to, you could draw another point on it. And now we have an angle that is X, Y, Z, and you can show it right here. And I know that this is 120 degrees. Please let me know if you have any questions. Otherwise, have a great day.